Okay, question number 8. We have a graph restricted to main from 0 to infinity. Okay, find the limit of g of x as x approaches infinity. So as x approaches infinity, I can see this is going to approach the asymptote, so it equals 0. That's what the limit equals. Remember, the limit will be what y will be if x could be infinity. If I was to look at this, e to the minus x is going to become e to the minus infinity, which is going to approach 0. And 0 times the cos of anything is going to equal 0. So 0 is the answer that the limit approaches. The general solutions to the derivative. Well, I've got a product rule. So u equals e to the minus x and v equals the cos of x. So I need to do the product rule to get the derivative. So u dash will be e to the minus x negative because the derivative of minus x is negative, and v dash is also negative sine of x. So g dash of x is going to equal e to the minus x negative times the sine of x plus negative e to the minus x times the cos of x. Taking out a common factor of negative e to the minus x gives me sine of x plus cos of x. If I set that equal to 0, e to the minus x cannot equal 0. Therefore, sine of x plus the cos of x equals 0, which means that cos of x equals negative sine of x. Divide both sides by cos. 1 equals negative tan of x. So tan of x equals negative 1. All stations to Columbia, first and fourth quadrants. 1 is pi on 4 in the first quadrant, so I'm looking at 3 pi on 4 and 7 pi on 4, and we're looking for general solutions. So x equals 3 pi on 4 plus 2 pi n, or 7 pi on 4 plus 2 pi n, where n is an element of all integers. So that's a 3 marker. Moving along, we end up with part C. We now have a continuous random variable where, lo and behold, that's this graph, except with the k in front. So the k isn't going to affect things. State the value of x which the maximum value of h occurs. The maximum value of h is going to occur either 3 pi on 4 or 7 pi on 4, because that's when the gradient is 0. Now, this is the same graph as this, except it's been multiplied by a negative k, and we're going from pi on 2 to 3 pi on 2, which makes me think that k is going to be a negative number, because I'm looking for this area here to be above the x-axis, so therefore it's going to look like this. And my maximum is going to occur here, which is going to be 3 pi on 4 from the last answer that I had, because I know it's going to be in the second or fourth quadrant. This 3 pi on 4 refers to this point here. The 7 pi on 4, that's that one there, and the 7 pi on 4 is that one there. So I'm going to say that x equals 3 pi on 4. I know it's not 7 pi on 4 because that's outside of the domain, because this goes from 2 pi on 4 through to 6 pi on 4, and 3 pi on 4 is the only one in there. And now we have a condition, integration by recognition. Okay, So given the derivative of this is this, so d dx of e to the minus x sine of x minus cos of x equals 2e to the minus x cos of x, which means the integral of e to the minus x, e to the minus x sine of x minus the cos of x equals 2 times the integral of e to the minus x cos of x dx. I need to find k. K is going to be the integral of this over this domain, and it's going to equal 1. So I know 1 equals the integral of k e to the minus x cos of x dx from pi on 2 to 3 pi on 2. So 1 equals k, integral of pi on 2 to 3 pi on 2. And if I mark that as being e to the minus x cos of x dx, and if I make that a 2, I can balance that out the front with a k on 2, which gives me 1 equals k on 2. This is this, which equals that. E to the minus x sine minus cos. Sine of x minus cos of x from pi on 2 to 3 pi on 2. So 2 equals k times e to the minus 3 pi on 2 sine of 3 pi on 2 minus cos of 3 pi on 2 minus e to the minus pi on 2 sine of pi on 2 minus cos of pi on 2. Now, here's pi on 2. The coordinate there is 0 and 1. So the cos of that is going to be 0, and the sine of 3 pi on 2, so we're down here, is going to be negative 1. And the sine of pi on 2 is going to be 1, and that's going to be 0. So 2 equals k, negative e to the negative 3 on pi on 2, minus e to the minus pi on 2. There's a negative there, there's a negative there. So I'm going to bring that negative out and put negative 2 equals k, e to the minus 3 pi on 2 plus e to the minus pi on 2. Negative 2 equals k. 1 on e to the 3 pi on 2 plus 1 on e to the pi on 2. I can build all these up to e to the 3 pi on 2. I need to multiply this one by e to the pi, e to the pi. No, I'm going to multiply this one by e to the pi over e to the pi. 1 plus e to the pi. So k equals negative 2e to the 3 pi on 2 over 1 plus e to the pi. And I think that's in the correct form that I want. And that is in the correct form. A is 2, B is 3 pi on 2. and C is pi.